Okay, so the next test under this exercise 3.5, the last test. Okay, so this test, write it down along with me. 3.5E, and this will cover exercise 3.5, question A1 to 5. This will find on textbook pages 64 to 65. 64 to 65. Okay. Now before we start, since this is going to use the three conditions for a pair of linear equations that we started with at the beginning, okay, it's good to remind ourselves once, so you can also write along with me. And we have those conditions. One is if a pair of linear equations is such that a1 by a2 is not equal to, or we can write it here, okay, that's fine, b1 by b2, then we know they have a unique solution. Means one value for x, one common value for y. Only one solution. Unique solution means only one solution, and they are called to be the graph will be like this. If this is the graph of the first equation, you can draw small AB, let us say, is the graph of first equation, suppose. Then the graph of the second equation also straight line, because linear equation means the graph will be straight line. They'll cut at only one point. That's why they intersect at only one point when they have unique solution. And so they have, since they are touching, the two graphs are touching, we call that as, and they have a solution at least, we call that as consistent. Okay, consistent means the graph are touching, or they have a solution, at least one solution, one or more solution. Then second condition I would like to put this way: if a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then we know the system, the pair of linear equations have infinite number of solutions, countless number of solutions. Such a case, if you draw the graph of the first equation, it will come out like this straight line, AB. So here AB is representing the graph of the first equation, and CD, let us say, representing the graph of the second equation. We're going to do this graphical method in exercise 3.2. Okay, so here, if they're coming out a1 by a2 equal to b1 by b2 equal to c1 by c2, we're getting like that. After we draw the graph, we'll find out that the two graphs, one of them AB, then the other will be CD, something like this, and the two will be parallel, means, not parallel, a1 equal to b1 by a1 by a2 equal to b1 by b2 equal to c1 by c2, means the two lines, they will have infinite solutions, and graph of first is like this. Then when you draw the graph of the second one, you'll find out interestingly that it is on the same line as the first graph. The two graphs are overlapping, so we call this as the two lines are coincident. So the intersecting at one point, intersecting at all points are coincident. And since the graphs are touching at least one point, here in this case, the two graphs are touching each other at all points, so it's still consistent. So the word consistent here means they have solution, unique or one solution, or infinite number of solutions. But if they have solutions, we call the system of the pair of linear equations as consistent. But the third case is a case of not consistent. So here, if a1 by a2 is equal to b1 by b2, but they are not equal to c1 by c2, then we know they have no solution. So no solution means inconsistent or not consistent. Inconsistent is opposite of consistent. Not consistent. Okay, and that means if you draw the graph of the first equation and you get something like this, AB is the graph of the first equation, let us say, and you were to draw the graph of second equation, you'll find out the graph of the second equation is parallel to the first, and they do not touch each other at any point. Therefore, they have no solution. They have no common value for x and y, that means. So these are the three conditions that we keep in mind as we do this test part. Okay, so let me just draw like this for space sake. Okay, so let's start with A1. A1 here, the pair of linear equations. So let's write it down here. The given equations are x plus y minus 40 equal to 0. Let's just keep it like this, because at least x term should be in the first place, especially in this exercise where we're dealing with the three conditions. X term should be in first place, y term in second place. And this is C1, the one having no x and y factor is called as C1, and C2 is on the left side or right side. It's okay, right? So the second one is, so the second one should be like the first then, x minus 2y plus 14 equal to 0. So this also okay. X term in first place, y term in second place, and C2 in second place, just like equation 1. So their pattern is identical or similar, or better word, similar. So that is okay. Why? Because we're going to calculate A1 by A2 and all this. If C1 is on the left side and C2 on the right side, this calculation for these three conditions will go wrong. Okay, so that's why. So question is saying the pair have, these two has 1, 2, 3 unique solution, exactly 2 solution, infinite no solution. So we have to find out by using this condition. So if we don't know what is the condition under which of these three it falls under, so we'll have to do separately A1 by A2, B1 by B2 like that. A1 by A2, let us calculate. As I've been saying enough number of times now, that A1 and A2 are the coefficients of x in equation 1 and 2. So you can just write like this if you want to make it more sensible or make sense out of it from equations 1 and 2. And then you write A1 by A2. Coefficients of x. So in front of x, no number means plus 1. A2 means the coefficient of x in equation 2. So in front of no, plus 1. So 1 by 1 is 1. Cancel it as much as possible and write in the lowest possible expression is called standard form. Comma, then B1 by B2. Let us do this. B1 and B2 are the coefficients of x, coefficients of y in equations 1 and 2 respectively. So B1 here in front of y, no number means plus 1. In front of y here, minus 2. So I just write like that. You can't cancel. If you can, you must. Okay. If there is a minus, we bring it up. So minus 1 by 2. So clearly we see that A1 by A2 is 1, B1 by B2 is 1 minus 1 by 2, so they are not equal. If A1 and by A2 is not equal to B1 by B2, like this case, like this one, then immediately stop, no need to find C1 and C2. You will find C1 and C1 by C2 only when A1 by A2 is equal to B1 by B2 like this, or A1 by A2 is equal to B1 by B2 like this. Then we'll go and find C1 by C2 to check whether it's equal or not equal. Otherwise, if they are not equal here, we stop. Okay, so we see that A1 by A2 is 1, B1 by B2 is minus 1 by 2. So these two are definitely not equal. Therefore, they have what solution? Unique solution. So which one match? Choice number A. So the answer is choice number 1, a unique solution. So that's how we do it. Okay. I'll go to number 2, A2. Let us go about it slowly. If a pair of linear equations in 2 variables is consistent appears here and here 1 and 2. This is not consistent, so maybe this or this where we focus. A pair in linear equation is consistent, then the lines represented by the 2 equations are intersecting. Here, intersecting, correct? But then that's not full, I think, parallel. No, this is inconsistent, so this is parallel line, so that's not the one. So it's always coincident. Half truth, but coincident means that lines are like this. Coincident means the 2 graphs are touching at all points, but this one doesn't touch at all points, so it's not correct, that one, coincident. Then go to the next one. Intersecting, here also the graph is intersecting, yes. Here the graph, 2 graphs are intersecting at all points, intersecting, that seems to be correct. Intersecting or coincidency, both are or coincident. Okay, consistent, this is called coincident, and coincident. So intersecting means they are coincident. That means intersecting or coincident. So you write there, coincident means consistent. That means coincident means they have a solution. Okay. So A2, the answer, simply you can write the choice. The answer for this 2 is choice number 4. The graphs intersect, so intersecting, that's talking about the graph. Or coincident, we can also call it as coincident. Why coincident? Because the graphs are at least touching at one point here, and it's all the points here. So coincident or consistent means the two graphs are consistent, means they have at least one solution. Coincident means it's talking about the graph. The graph is at least touching. Coincident. Okay. Intersecting or coincident. So number 4. That's your answer. Now let's go to A3. Once we're done, let me read. If a system of equation 2x plus 3y, so let's write down here. Two equations given, 2x plus 3y is equal to 7. Put as equation 1, and then 2ax, so the x term is still in the first place here, so that's okay, plus bracket a plus b into y, so y term here, x term here, that's okay. Then the term having no x and y, 28 is on right side, here also 7 on right side, so the pattern is similar, so that's correct. X term in first place both, y term in second place, C1 and C2 on the right side, so that's okay. One on right, one on left, not allowed, right? Because we're going to use these conditions. Has infinitely many solutions, so we can just write down here. So infinitely many solutions is this one. So we're going to have to use this condition too. Since according to the questions, the given pair, let's use the same language of the text, given pair, a system of equations. Okay, they're using systems. So the system of equation, the system of the given, if you want to write that, the given system of equations has infinitely, many solutions. So which is the one having many solutions? This one, see, infinitely many solutions, or infinite, this is not no, okay, the infinite no means, I mean to say here number, infinite number, so infinitely many solutions, so infinite number of solutions is same. So this condition, so let's write here, a1 by a2 equal to b1 by b2 equal to c1 by c2, because the question clearly says they have infinite number of solutions or many solutions. So that implies a1 is the coefficient of x, so here in front of x2, so that is a1, and a2 is the coefficient of x in equation 2, so in front of x right here, 2a, everything in front, so plus 2a is equal to b1 is the coefficient of y in equation 1, so here plus 3, and b2 is the coefficient of y in equation 2, so in front of y is a plus b, so I write here a plus b is equal to c1 and c2 are the numbers or expressions having no x and y terms in them here, 7 and 28. So 7 is c1, 28 is c2. So they're saying choice 1 a equal to 2b, choice 2b equal to 2a, a plus 2b equal to 0, a 2a plus b equal to 0. So a and b are involved. So first, second, third part. First part equals, second part equals. So first, second, 3 parts are here. First and second part has got a and b, and the answer choice is given in terms of a and b. So you can just neglect the last one. So taking first and second parts, right? First part is 2 by 2a is equal to 3 by a plus b. So these 2 and 2 can cancel 1. The next down and up you can multiply a into 3, 3a, then equal 1 into a, 1 into b, so plus b. And bring the a terms on one side, 3a, no sign in front of a is plus, so plus a shifted from right to left becomes minus a. Here b. So we know that 3a minus no number here means 1. So 3a minus 1a is simple as 2a is equal to b. Answer choice matching this one is b. So we can write here this b is therefore equal to 2a. Choice number 2 is the answer because there is exactly this one. Choice number 2 where it shows b equal to 2a. Okay, I hope you're getting it now. A4. Let's go to A4. A4, subheading 4. If the lines given by these two equations, so let's write here the given equations. 3x minus 4y plus 7 equal to 0. Let's write this one as equation 1. And kx plus 3y minus 5 equal to 0. Let's write this as equation 2. It's okay because the pattern is matching is here. X term in first place, y term in second place, and c1 and c2 in both on left side in equations 1 and 2. We have to particularly make sure that the pattern matches before we start solving, okay, in this exercise especially. Because we're doing the conditions for linear equation, the three conditions. Okay, so here we have to find the value of k. So for that, if the lines given by 3x minus 4y plus 7 equal to 0 and kx plus 3y minus 5 equal to 0 are parallel. Parallel means this is the parallel line, which means I'm going to use this. So we write here, since you can just use the same language as the text, the lines given by the given equations means pair of linear equations are parallel. Therefore, the only case where they are parallel is the third case is here, parallel lines. This is the condition. So a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. Only then the graph of the two equations are parallel. So this is the condition we're going to have to use to find k, which the question is asking, find the value of k. Then the value of k is what? A1 is the coefficient, a1 and a2 are the coefficients of x here. So in front of x, 3 and k. So I write here 3 by k. Okay, equal to b1 and b2 are the coefficients of y. So here y. In front of y, minus 4 by 3. Minus 4 by plus 3. No sign put is okay. C1 and C2 are here, plus 7 minus 5. So plus 7 is C1, minus 5 is C2. So they asked us to find k. So this part can be neglected because this is not equal to, and these two parts you take. Therefore, we can just take the first part and the second part, because first part contains k and that is equal to the second part, which is a constant number. And we reject the third part because there is a not equal sign here. Okay, so we can just reject. So k into 4 is 4k, then plus into minus is minus. So minus 4k. So we're getting here minus 4k equal to 3 3s are 9. We don't want minus involved, then you can change this to minus 4k to plus 4k. Then the sign here, no sign, plus 9 will also change. So we're getting the value of k as minus 9 by 4. So if you divide 9 by 4, because 4 is in the denominator, so that's the divisor. 4 2s are 8. Okay, 4 2s are 8. 1 in hand, no more number means point you can put at 0. 2s are 8, 2 in hand. Point means we're allowed to put at least 1 0. So 4 5s are match this one, 20 exactly going. So this is minus 2.25. And the answer matching there is therefore number 2, which is exactly our answer, matching 2.25. 2.25. Okay, so last question left, A5. Let us go there and do it. Okay. So let me read the question. The pair of linear equations 3k plus 1 into x plus 3y minus 5 equal to 0 and 2x minus 3y plus 5 equal to 0 have infinite solutions. So infinite solutions is this one. We are going to use this one this time. Infinite solutions, then the k value is what? So here let's write the equations first. First one, 3k plus 1 into x, this is the x term, plus 3y, this is the y term, minus 5, this is c1 on the left side, equal to 0. Let us put this one as equation 1. Then the next one is 2x, that is the x term in first place, so that's fine, minus 3y, y term in second place, that's fine, plus 5, that's c2 on the left side, so that's also fine, equal to 0. This is equation 2. Since question has said the pair of linear equations, we can just use the same language as text. That's always easier. The pair of linear equations have infinite number of solutions. So infinite number of solutions is this, so we're going to use this. So we're going to replace this one now. So this one here, a1 by a2, therefore a1 by a2 equal to b1 by b2 equal to c1 by c2 is this c here. Exactly the condition we're going to use. So a1 and a2 here are the coefficients of x, which are in front of x here 3k plus 1 on the numerator, a1 by a2 here in front of x is 2 equal to b1 and b2 are the coefficients of y here, plus 3 here, minus 3 here, so plus 3 by minus 3. c1 by c2 are the numbers with no x and y factors, so here minus 5 c1 plus 5 c2, so minus 5 by plus 5. So we can cancel out this one, then 1 1 1 1. You're getting here 3k plus 1 by 2, and if you have minus in denominator, we can always bring it out. So minus 1 by 1 is 1, or minus 1. Here minus 1, so equal to minus 1 equal to minus 1. So 3k plus 1 by 2 equal to minus 1, either this or this. Don't take both, just take one. Okay, then because we can now find k. So minus 1 means by 1, so 3k plus 1 into 1 is 3k plus 1 is equal to, plus and minus is minus, 2 ones are 2. So 3k, don't move that because it contains the k, and this minus 2 also same, and plus 1 shift to the right side, all the numbers shifting to same side. So you're going to get 3k equal to minus 2 minus 1 is minus 3, because when both are minus we add, and when both are minus the sign after adding is minus. Then here, as we continue doing, you can write these things on graph if you want, or if you are quite comfortable, that's fine. Okay, don't move that, and minus 3 on right side, same. Between 3 and k, no sign means 3 into, so 3 into shifted to right side, and we'll go to the denominator. 3 ones are 3, 3 ones are 3, so k is minus 1 by 1 means minus 1. Therefore, the answer choice that matches the fourth one, where k value is mentioned as minus 1. That concludes the part of our exercise 3.5 and all the tests. Okay, next we'll move to the next new exercise. Okay.